Yes, now we are talking about Sri Lankan situation. Home for 21.9 million people. It's 0.27% of the world population. The population density is 349 per square kilometer. The total land area is 62.710 thousand square kilometer. 18.7% of the population is urban, and median age in Sri Lanka is 33 years. And life expectancy is 76.8 years. These are updated values. You can see that we cannot live long because our median age has been reported as 33 years. Okay. Then there's another term, Human Development Index. Human Development Index is a statistical tool used to measure a country's overall achievement in its social and economic dimensions. Social and economic dimension. So human development is social development plus economic development. And you know that sometime when we are discussing about this Human Development Index, we can increase this by increasing social development. We can get a loan from another country and we can improve our social status. Then Human Development Index is increasing. But the real problem is, can we increase economic dimensions of this particular index? Then there's another one, poverty headcount line. Percentage of the population living below the national poverty line. National poverty line, although we say national poverty line, it varies from district to district. It varies from month to month. So we will get an average value for the country. If the people who are below this line, we call they are poor people. So the poverty headcount line is the percentage of population living below the national poverty. So Human Development Index, this is the report from 2018. 0.782 ranked 73 among 191 countries. Somewhere average. 0.625 in 1990 increased to 0.782 in 2021. I think now it is again decreasing. Poverty headcount reduced 46.8 from 46.8 to 14.3. That means we are having some sort of hopes. Unemployment is 6.71. This unemployment means these people are there. People can do a job, but no opportunities. That is unemployment. That is 6.71 as reported in 2022. Economic GDP, US dollar billion, 88.93. Per capita, US dollar 3,360. Because of this, our global scale analyst, they say that we are in a middle income economy. GDP growth rate is 3.1 in 2017, 3.7 in 2019, and 1.3 in 2020. So it's a decline in growth, it seems. Composition of GDP, agriculture 14.6, right? Industry 26.2, other services 59.2. So export revenue is in 2017 is US dollar 11.08 billion. This is the situation that we have in Sri Lanka, most updated things. So shall we turn into the discussion today we are having? Agriculture production. When you say agricultural production, it is governed by three set of factors. One is climate, we know that, climate. The other one is soil base. And the third one is crop. There are many others, but we have to classify this one, mainly these three different determinants. So climate factors: precipitation, air temperature, relative humidity, light, so altitude, latitude, elevation, wind, and carbon dioxide concentration. Then soil factors: organic matter, texture, structure, cation exchange capacity. I think you have already learned something in your basic degree period. You may be sometime forgotten, but anyway, we will brief it again. And you have to know this, what they are. Base saturation, slope and topography, soil temperature, soil management factors, that means tillage, drainage, and others, and root zone, how it extends down in the soil, that is effective soil depth. And crop factors, crop species or variety, planting date, seeding rate and geometry, seed quality, evapotranspiration, water availability, nutrition, pest, and harvest efficiency. Now we have discussed about three set of factors. We can discuss now how climate and soil affect agricultural production. We have different resources on the earth. There are a lot of resources. We call in common earth resources. Resources, something we can use to benefit our living. The earth has many resources that benefit us. We call them as natural resources. Some of these we get from the earth are water, air, sunlight, soil, plants, animals, rocks and minerals, and fossil fuels. All these are resources, right? If you can use it effectively, many of these are renewable. At the same time, some of them are not renewable. So we call non-renewable resources, like these fossil fuels, right? Minerals, rocks. Now, when you say resources, these resources can be replaced and reused, then we can say renewable. Air, fresh water, soil, living organisms, sunlight. Some resources are there we term as non-renewable. Fossil fuels, diamonds and other precious gems and minerals, types of metals, ores, etc. If you go through carefully, water resource, total global water, most are there as ocean water. There are small amount of water compared to this ocean water, 0.9% saline water. Then about 2.5% only fresh water. So out of this 2.5, we have 68.7 glacier and ice caps. Those are fresh water, right? Then there are groundwater, 30.1. So altogether, this surface water here is about 0.03 of the global water. Then out of this fresh water, we can see that again, ground ice and permafrost 69%, lakes 20.9, and so many things here. You can see that very small amount is there we can use. So that is only 0.03%. Out of that also, we have some difficulties of using most of these water resources. Some are in lakes, some are in ground ice and permafrost. You see the limitation of water resource when we are going to use it. Very, very minute amount. So that it indicates that we have to conserve that and use effectively and efficiently. This is land resource. Now here you can see that 29% of the land resource is earth surface. In the ocean, 71%. Then out of that, 20.6% is habitable land. Out of that, 50% of this we are using for agriculture, and that is 10.3 of the whole land resource. You can see the limitation of land also. And also from these lands, agricultural lands, most of this land resource, 77% is utilized for livestock. So agriculture is very small amount, including these crops and rain-fed crops, irrigable land, everything. Climate is governed by many factors. If you take Sri Lankan conditions, we have 3 topographic zones. One is that the Central Highlands, you can see here, Central Highlands. That is in between 750 and 2,500 meter elevation. Then after that, you can see this yellow color, that is plain. It's between 125 and 750. As we expect, the coastal border, right, we have less than 125 meters. So that it's a combination of different elevation ranges. You can see that the slope towards radially towards all these coastal areas, these are creating a lot of rivers because of the rainfall and runoff. There are 16 principal rivers, and this has been recognized and identified by our ancestors also. These 16 principal rivers, they have put these 16 rivers into 10 kingdoms, right? And they have ruled in different era. So they have used these 16 principal rivers. Out of them, 12 rivers carry out 75% of the main river discharge of the country. The longest river is Mahaveli. We know that it's about 335 kilometers. So we have a lot of knowledge on water management, water resources management. Still, you can see that many rivers yield about 60 to 70% of annual recharge to the river and the land is going to sea. And also in some rivers like Yangwaya, Kalawaya, Daduruwaya, and Malotuwaya, those rivers yield about less than 20% annual discharge into sea. So you can see the situation, and it is very unfortunate that we are getting flood in one place and the drought in the other place at the same time. So this is the reason. And if you discuss about weather and climate, we call weather, sometimes we call climate. Sometimes we confused which one we can use. These are not the same. Weather is the conditions of the atmosphere at a particular place and time. So it will vanish. That is weather. Climate is average conditions of a certain place over a long period of time. So we will collect data for a long period, at least 20 years, and get the average. We call this is the climate of this area. So climate is what you expect, and weather is what you gain. So that is the difference. And we have climatic seasons. Four climatic seasons due to monsoonal rain seasons. If you start from first intermonsoon, that is from March to April, this is in general, right? Then southwest monsoon, that is from May to September. That is the wind direction is southwest. Then second intermonsoon season, that is what we are experiencing now. That is from October to November. Later on, you can find after 15th of November, you will find northeast wind direction. So it is called northeast monsoon. It will go on from December to February. So these are the climatic seasons. Now we have rainfalls, right? Rainfalls we get sometime from northeast monsoonal winds coming from Bay of Bengal. The other one is southwest, the other direction. So rainfall we have categorized into three: dry zone, intermediate zone, and wet zone. You can just think about where you are in the dry zone or intermediate zone or wet zone. Dry zone will receive average annual rainfall of below 1,750. If it is 1,750, 2,500, that will be there in the intermediate zone. Wet zone is it's about above 2,500 millimeters. So that we see the amount of rainfall. It doesn't indicate any other things, only amount of rainfall. If you look at this one, you will find dry zone covers a lot. Then intermediate zone here and the wet zone there. How we can have this one? When we have southwest monsoon, the wind direction is in this way, and because of this central highland, you will get more rainfall here. And it is a smaller area compared to this one. The other way, when you get northeast monsoon, it comes and it will be blocked here due to central highlands, and you will get here the rainfalls spread here, and it is lower than here. So we call wet zone here, we call dry zone there. And what is in between is that intermediate zone. So when we are trying to prepare this agroecological map, earlier we had 24 agroecological zones, rainfall and even altitude. So dry zone, intermediate zone, wet zone, and there are some other subzones. Out of these 49 subzones, we have wet zone 16 subzones, intermediate zone 20 subzones, dry zone 13 altogether. It's about 49 subzones, right? Then how we can denote this? So we can say DL1, DL2, DL3, DL4, DL5, etc. At the same time, we have another small letter followed by DL1 or these 3 digits. So we say 3 major rainfall zones are indicated by the first uppercase letter of the code: wet zone, intermediate zone, and dry zone. That is okay. Then 3 categories of elevation are noted by the second uppercase letter of the code: low country, mid country, and up country. So earlier we have wet zone, intermediate zone, dry zone. Now second letter is low country, mid country, and up country. Then we have another numerical value that is for degree of wetness. It ranges from 1 to 5, where 1 represents the most favorable. You know, you can imagine that is because of the landscape, at the same time soil. When you get more water infiltrate into soil and store there, that is more moist, and it will be somewhere towards 1. Then there is another one here. The lowercase letter in the 4th place indicates the sub-region as determined by rainfall and other physical environmental factors. Again, we have from A to F. A is the most favorable, F is the most critical. This is wet zone climate. You can see here a lot of subzones. W, yes, that is for wet zone. Then up country, mid country, and low country. Then there are some other subzones. Then here the intermediate zone, you can see intermediate, up country, mid country, and low country. So in up country, mid country, and low country, we have intermediate zone. At the same time, we have wet zone. If you look at the other one, dry zone. You have dry zone here, but we don't have any up country or mid country. We have all low country here, and you can see that we have here DL4 region and here DL5 region. Why we want to have these kind of extreme ends here? Because of the wind direction and the blocking effect of this central highland, so that you will get less amount of rainfalls this side and the other side. So DL3, DL4, and DL5. Now we are observing some trends. although we say DL4, in manner, sometime it will go in time to DL5 sometime. Yes. Soil factors. Something very important here. We want to know about soil factors. One is the amount of organic matter in the soil as a percentage. You see, in under forest we get about maximum 2.5%, right? Then in cultivated lands, it will come down to 0.8, 0.7, 1.1, etc. So that we call land has been degraded. If you can keep on adding organic matter, that's good, but you can't achieve this forest condition as 2.5%, right? Then the texture. Texture is the composition of soil, sand, silt, clay, etc. Then structure, how it is formed. It will be loosened structure. It will be hard structure. If it is too hard, it's not good for crop growth. So we'll have to loosen the soil by plowing or adding some organic matter. Then there's another peculiar thing, cation exchange capacity. I will explain this one because sometimes it will not be clear for you why we want to talk about cation exchange capacity. Then base saturation, I will talk about that. In addition to those, we have slope and topography, then soil temperature, then soil management factors like how we can manage the soil by using tillage, by using drainage, and so many other factors. Then the last one is depth to depth of the soil within this root zone. We call effective soil depth. So we will take cation exchange capacity now. Cation exchange capacity, you can see here. This is a particular clay, small block of clay we call units. We have negatively charged particles here. So it will attract positively charged particles like calcium, magnesium, potassium, and sodium. So these are the clay particles charged with negative charge. Then you know that these positively charged ions can be exchanged. That is the ability of this clay particle. Even in organic matter also, we can see the same thing. And when you have a soil solution, part of this will go to the soil solution. Part of that hydrogen ions are also in the soil solution. This soil solution, as you know now, we have these alkaline ions, at the same time hydrogen ions. Then this is cation exchange capacity. We can have in 3 ways. And you have sodium, potassium, calcium, magnesium here. How we can calculate that? You can read it, no problem. Valence is sodium 1, potassium 1, calcium 2, magnesium 2, etc. So that we can finally milliequivalent weight can be calculated by using these values. What I want to tell you that now this is sample calculation, right? If you have any problem, please tell me, I will explain again. Now, here we can see cation exchange capacity can be divided into two. One from organic matter, the other one from clay. You can see this cation exchange capacity is not there in the soil or not there in the organic matter. What will happen if you pour some water? It will go through and it will wash away all these cations. If you don't have this capacity, because you have this capacity, you can get a lot of benefits. This is how to predict this. One is we can calculate the whole total of cations. The other one is we can put ammonium solution there and we can find the replaced cations, how much. Then we can have an estimate on texture, sand, loam, clay, and we can calculate how much the cation exchange capacity of this particular soil. Now we know that if you have high CEC value, okay, that means it's about greater than 25 because of sometime organic matter. This is very good soil for agriculture. But when you have soil with a low cation exchange capacity, it's a good indication that the soil is sandy with little or no organic matter that cannot hold many cations. So sandy soils, we have less CEC, and clay soils with organic matter, we have high CEC. Before that, I just want to tell you something here. Now we know that there are cations: calcium, magnesium, sodium, potassium. Then we have another cation, hydrogen. When you have more hydrogen, that means more other cations are less. That percentage is we call base saturation. If you have more cations instead of hydrogen, we can say base saturation is very high. If you have more hydrogen ions in the solution and less amount of other cations, we can say that base saturation is very low. This is also important in our agricultural activities. Then this is the soil map, how the soil varies from place to place. You know that there is one well-known soil, reddish brown earth. In most of the cases, it is laced with low humic clay soils. All these pink color you can see here. And if that is a river or stream, you can find alluvial soils, that is sandy layers. Then here you can see another strip of lands just close to Mana. This is well known because of the civilization has migrated from here to here through this soil belt. This is called red and yellow latter soils. Then there are patches, pockets. We have some other peculiar soil, non-calcic brown soil. Earlier, our scientists named that as non-calcic brown. That non-calcic means no calcium at all. But it is not. Calcium is low in these non-calcic brown soils. And also, I think we are going to discuss about this one. It's sandy soil layers on this one. And later on, we can have a hard pan, and it seems to be that well drained, but it is not. Then we have some other soil type, red yellow potsolic in the wet zone area, right? Generally, these soils can be utilized for many purposes, many crops. But in general, we are using reddish brown earth for all these grain legumes and maize, low humic clay soils for paddy, red yellow potsolic for plantation crops, The non-calcic brown, big onion and red onion, you can see that shallow-rooted crops. Then red yellow latasols, cashew plantation, sandy regosols in Putlam, Nigambu, and Chilau area, you can see coconut. Then alluvial soils, which are located in this located in this riverine areas. That's also good for paddy. Then gumsols in the upper part of the country, paddy, and immature brown lawns we can use for home gardens. Do you have any problem? Anybody? Please tell me, then we can have an excuse. No one, right? Okay. Then reddish brown earth is a very well-known soil, and it covers in the dry zone a lot. And there are differences from place to place. That covers the largest extent of the land in the dry zone. Color is reddish brown, sometimes dark reddish brown, sometimes yellowish or pale reddish brown. Because of the variations, we have series. Now, these groups, soil groups, can be categorized into different series. For example, in reddish brown earth, we have Medavachya series, Aluttav, Anamadu, Ranorav, Tadaratu, then Simalandu, Ranna, Nonagamu, Kotaveram, Mankad, Valave, Uliti. Now, you can see all these village names are from different locations in the dry zone. So that we name it where we get this benchmark soil sites. And also the other good thing that we have, this landscape is undulating. So you get upper part here, middle part here, lower part here, bottom lands here. Then if you take effective soil depth, very shallow soil depth here, moderate here, moderately deep here, very deep here. Then if you take the drainage, here well drained, then imperfectly drained, and poorly drained. You have to make a note in this that when you say well drained, if it is the land, it doesn't mean that water is drained very easily. Imperfectly drained, water is drained not that much easy, and poorly drained, it doesn't mean that water is drained poorly. But the problem is, if it is not there, at the same time, well drained there, you get easily drained, but it is not the indication that say well drained. If you take groundwater table, it's here like this, and groundwater table is very far below than well drained. Somewhere here, imperfect drain, it fluctuates along the year. Poorly drained, you can get water table almost on the surface. That is why we say those are poorly drained. RB soils, generally it is moderate soil depth, 60 to 150 centimeter. Then texture is sandy clay loam. You must be aware that we have a textural triangle. According to the composition of the sand, silt, and clay, we will feel different textures. Structure is how it is formed, how it is structured. Then this RV soils is strong subangular blocking. So this is the one that we have. Then available moisture per meter of soil, we can have 130 to 170 millimeter. That depends on the porosity. So we have porosity in different terms. One is that micropores, the other one is macropores. Consistency, RBE, when we have a dry soil, it is too hard. Even you cannot plow. You can use memory to break it down. When it is moist, slightly friable. And it's good for the tillage practices. Then if you have very high amount of water in the soil that is wet, very sticky. So these particular properties will tell you when you are going to plow, when you are not going to plow, right? Now, when you have a rainy season, it will start from the dry soil. When you have dry soil, you can't plow. Very difficult. Then when you have some sort of rainfalls, which will moist the soil, then you can plow it. But when you have more and more rains after some time, the soil will get sticky, so that it is very difficult to plow. What we have to do is to broaden this window by having some strategies. One is that we have to incorporate more and more organic matter. Now, you know that in rain-fed cultivation, people used to use this land for OFC cultivation, especially maize, rain-fed uplands. Then they want to plow first. Later on, they want to use chemicals. Why we want to do these two? Because when you say land is degraded, it is compacted. Because of that, we want to plow. The other one is land is degraded chemically. Because of that, we have to add more and more fertilizer. So that people they dump a lot of chemical fertilizer into this soil. And also they will break all these compacted soil by using tillage. So those are costly. What we suggest that we don't have those kind of operations earlier. And the people in the past, they manage this soil continuously by using organic matter and conserving the soil, preventing a lot of soil erosion. This is reddish brown earth soil. Generally, it has person clays here, then person sand here, and the other one is person clay. Sorry, person clay. The other one is person silt. Person silt is somewhere here. So these proportionately indicate the composition. So when we have these particular percentages, we can put this in the textural triangle and say it's sandy clay loam. Then the other one is low humic clay soils. Can you tell, somebody can tell me when I am going to explain this, if you feel any difficulty of understanding? whether you understand or whether you don't understand or whether you understand partially or something like that, then I can correct myself. Or this is the way that we have to learn. Change. Sorry? Sorry?
Understood, sir. Understood.
It's okay.
Okay, sir.
Okay, thank you. Then now we have discussed about reddish brown earth. Now we are discussing about low humic clay soils that is always associated with reddish brown earth. Reddish brown earth is in the upper and middle part of the Katina. Then low humic clay soils in the lower part of the Katina or the valley bottom. So this is the third most extensive soil group in Sri Lanka. Located at the foot slopes of the undulating landscape, characterized by the wetness or glaying through the profile, that is we call glay, available of calcite concretions, that is another phenomenon I will explain later. So texture is sandy clay to clay, structure is some angular blocky to massive, water holding capacity is somewhat good. So these are the common type of soil structure. We have different soil structures. Sometimes you will see that columnar, massive, platy-like, this crumbs, this granular form, blocky like that. This is low humic clay. So it's not sandy clay loam, but it is going up with high percentage of clay. So we call sandy clay here. Okay. Red yellow podzolic soil, the second most expensive, that is in between reddish brown earth and low humic clay soils. This is the second most extensive soil group in Sri Lanka. Model soil of the wet zone of Sri Lanka. When you go to Gampaha area, so wet zone areas, Nigambu, Katunayaka, you will find this red yellow podzolic soil. Earlier, we used the term laterites, lateritic soil, majority found in the hilly part of the country. Color varies from strong brown to yellowish brown. Now you can see that Minuangoda, Galigamu, Pallegoda, Omagamu, Borulu series, Agalavatta series, Dodangoda, Malaboda, Mattakale, Horton, Nuvareli, Muskeli, Veddagala. So all these areas in the wet zone especially, you will find this red yellow podzolic soil. So red yellow podzolic soil, when you travel on these lands, you will find this kind of gravel on the surface. So this is a deeply developed soil, higher structural stability, and better response to management. Moderate CEC, now you know what CEC means. Low pH, that means a bit acidic, prone to erosion due to steep topography. Now I want to tell you that soil erosion is different from place to place. Sometimes it is due to slope, sometimes due to structural instability. So that you have different erosion rates. So we will discuss sometime later. This is non-calcic brown soils. You get in Arlagamville, then Valikand, Madura area, you will find non-calcic brown soils. It's very tricky. If any stranger comes to this place and see that the sand layer, he will tell that this is very well drained, but it is not. This is a sand layer, and you will find here hard pan. After that, you will find different soils, but this hard pan will hold water without releasing, so that it will inundate the land after 1 or 2 rains. So that why people are cultivating shallow-rooted soils, shallow-rooted crops like groundnut, onion, because of this hard pan. The other one is that they cannot use some very moisture not tolerant crops like very sensitive to moisture levels. You cannot use it like chili and even maize. Then it will get destroyed because of this inundation habit of this soil. Color ranges from dark brown to ash brown. The soil contains mostly sand and a hard pan exists below with a sand and clay layer, especially 1 to 1.5, sometimes 2 feet sand layer. It inundates easily with rains, slightly acidic and enriched with calcium and magnesium. Cation exchange capacity is moderate, 5 to 11. Structure is breakable, so it doesn't have good structure. This is distributed in Ampar area, Betikalo area, some areas of Galgoi Valley, and area around Mahu. And also, I want to tell you that even in Maduro area, Arlagamile, you will find this non-calcic brown soils. So you can find a lot of crops they are growing, even cereals, green gram, cowpea, groundnut, sugarcane, chili, vegetables, and onions can be cultivated by applying correct conservation techniques and better irrigation. But we'll have to be very careful about this depth of this and inundation. Because of that, we have to provide very good drainage. Otherwise, these crops will be affected. Land resource. Sri Lanka, the total land area of Sri Lanka besides the area occupied by inland waters is only 6.44 million hectares. You know that the whole area is about 6.54 million hectares. Out of that, 6.44 is the terrestrial area. Then land-man ratio is low, which is only 0.37 hectares per person. Earlier we had a very high value. Now it's very, very low. Only about 2.5 million hectares, nearly 39% is available for further settlements and agricultural production. Therefore, the per capita extent of cropland is as small as 0.14 hectares. Now, per capita extent is again like land-man ratio, but it is not the total land, but for the croplands, it's about only 0.14. Sometime you will see that the average agricultural land size is 0.14 hectare. The major land use sectors in the country are agriculture, especially paddy, tea, rubber, coconut, and other perennials, non-perennial crops, and also livestock grasslands, close canopy and sparse forest, home gardens, and others. So we have different types of purposes for different land sets. You can see the landscape here, the hilly slopes and also flatlands. When you look at use of land resource, you will find home gardens about 15%. This ratio is stable in all areas of Sri Lanka. Paddy 8.8. Then you can have forest plantation, sparse forest, close canopy, natural forest. So all these forests will come to about 30. Then other perennials, 11, coconut 6, rubber about 2, tea 3.4, other land uses 21.5. This is the present land use system in Sri Lanka island. Now, how we know that because of the cultivation, because of the clearance of forest, we get a lot of erosion and also land is being degraded. Now, people can observe that is being degraded. One is that you can see soil loss, heavy soil losses. Similarly, you can see high sediment yields into rivers and reservoirs. And you can find season by season your soil fertility is declining, and as a result, crop yield is reduced. Then marginalization of agricultural land, there are limitations. Then sometimes soil development can be seen in some places due to poor drainage. Then landslides, that is due to exposure of this forest land or land due to urbanization or agriculture, and the deforestation and forest degradation. So those are the indications to see that the land has been degraded. Land degradation, how we can interpret that? Land degradation is the depletion of its physical, chemical, and biological productivity. If your land is not degraded, it is rich with physical, chemical, and biological productivity. To maintain the long-term productivity, what we can do, we have to do land management on a sustainable basis. Okay? So sustainable land management we have to use to meet human needs while ensuring long-term production potential and maintain ecological functions. This is the real definition of sustainability. In 1970s, people declared, our scientists declared that sustainable development. That means you can use the resource and also should not allow it to be degraded. So the similar way, we can define sustainable land management also. What you mean by land? Land is soil, water, flora and fauna. So sustainable land management means you have to manage soil, you have to manage water, you have to manage flora and fauna. So that means all together we can see the ecosystem in a more practical manner. That means land degradation is long-term depletion of the productivity potential and function of the ecosystem. When land is degraded, you will find that soil is degraded, water is degraded, and flora and fauna also are degraded. So that ecosystem has been degraded. What we have to do, so the sustainable land management, if you are going to try for any area, you have to keep in your mind that you are going to maintain the production potential and functions of the ecosystem. Now, when we say agriculture, agricultural productivity, any agricultural land has its own ecosystem. We call agro-ecosystem. So we have to manage this agro-ecosystem on a sustainable basis. You can see that sustainable ecosystem management system. Ecosystems. I am not going to tell you much about ecosystems. So it is another kind of analysis that we have to say. up to biome from organisms. In between, you will find ecosystems. So there are different types of ecosystems, mainly forest and related ecosystems, that is tropical forest types, riverine dry forest, grasslands, etc. Then inland, wetland ecosystems, floodplains, swamps, reservoirs, wet willows, marshy lands. Then there are some other ecosystems, coastal and marine ecosystem. If you go to Batikalo, you will find that mangroves. So that is the coastal and marine ecosystems. People will sometimes think that these some ecosystems are useless, you can't use it, but you know that these ecosystems are integrated and will provide various multiple purposes. So you can't just say that mangroves are not useful and you will have to destroy. No. Mangroves, salt marshes, sand dunes and beaches, lagoons and estuaries, coral reefs. I can remember one time we had a project and we wanted to study the freshwater problem in Jaffna area. So that what one solution is that you can convert this lagoon water into fresh water. How we can do it? Because of this rainfalls, you will find a lot of water in the lagoon and it will go to sea. Yes, it can go to sea. And if there is less amount of loss volume of water in the lagoon, then sea water will intrude. Right? That is the way that it happens to maintain these particular ecosystems. But there is a way that sea cow system, barrage with a valve gate, which will allow all excess water from the inland to sea, but not from sea to inlet. So that after 10-15 years, you will get the water as fresh water, reducing the salt amount in this water. So that way, we can supply fresh water to Jaffna area. So we had 5 barrages like that. Even Elephant Pass also, we had the same. So that ecosystems are changed, so that some environmentalists are against this change in ecosystems. So that means they did not want to allow this one. Because of this, some flora or some fauna will be distinct after some time, disappear. Ecosystems, when we learn that ecosystem, how we can, why we want to maintain this one, there are different purposes and services. So services and functions of ecosystems we have to know. One is supporting services. Supporting services means it will help maintain the conditions for life on Earth. So that ecosystem itself will be there to get the support from ecosystem itself. So it is there to replenish whatever that is lost, regenerate whatever that is lost, so that there are a system of supporting services within the ecosystem. Soil formation and retention, nutrients cycling, primary production pollination, seed dispersal, production of oxygen, provision of habitat. That means the system itself has the ability to keep it as it is. So that is supporting services. Then regulatory services, we have different things like water will be polluted, flood will take place, drought will take place. Sometime high winds will disturb our whole agricultural lands, like that. So that regulatory services of an ecosystem is to maintain the air quality, regulate the climate and water, control flood and erosion, purify water, treat waste, then detoxify, then control the human diseases, then biological control of agricultural and livestock pest and disease, and storm protection. So those are the regulatory services. In other words, if there's any kind of shock to the system, it will be taken care of by these regulatory services. Provisioning processes. Provisioning means providing the products from the ecosystem. So that is for humankind, especially food, fruit, vegetables, then wood, fuel woods, fiber, biochemicals, natural medicines, genetic resources, ornamental resources, and even fresh water, minerals, sand, and other non-living resources. So all these are provided by the ecosystem for the benefit of people who are around. Fourth one is cultural services. Now we have provisioning services we have, so that can be provided by the system. Then regulatory services we have that can regulate whatever the disaster, the shocks coming into the system. Then supporting services. The other one is cultural services. So cultural services is non-material benefit obtained from the ecosystem. One is diversity. Then spiritual and religious values. Ecosystem will provide a lot of things. Like for example, here in the tank, you have lotus, and you can take this to worship to the temple. Knowledge systems. They have a knowledge system, this knowledge base for thousands and thousands of years. So sometimes we can see that we don't find the good scientific base to explain this knowledge system, but it is happening there, and it has been experienced for more than 1,000 years. Then educational and aesthetic values are there, social relations, sense of place, cultural heritage, recreation and ecotourism. That's another new way of valuing the sun as cultural value. There's communal and symbolic. So there are things that we don't want to go into detail, but these you need to study and understand later. What is the value of this system as far as cultural services are concerned? Then genetic resources. So genetic resource means genetic materials of living organisms for our usage. So it includes animals, plants, microorganisms, and invertebrates used as food in agriculture and in forestry. Then important for sustainable food security to resolve the problem of narrow genetic base, and it's a value of local land races in plant breeding. So you know that even in the forest, you will find a lot of species we call land races, and that can be used to breed our crops to improve their properties, right? We can have a lot of examples from our surrounding. We have some similar crop type wild species. We call land race is a domesticated, locally adapted traditional variety. Land race, we don't want to say it's a variety, but it's a traditional variety originated from this one particular area. Then cultivar is a shorter form of cultivated variety. It is selectively bred to conform to a particular standard of characteristics. When we need drought resistance, we have different cultivars. Then when we have pest resistant tolerant varieties, then we'll have to take about different set of cultivars and breed. Then plant germplasm is the genetic resource materials used by plant breeders to determine cultivars. So these development, they use different things. Breeders, one is the cultivars. We are cultivating different varieties in different places, so we can collect it. Then land races, the people have their own family secrets and do some kind of varieties there that also can be collected. At the same time, we have plant germplasm in our plant genetic resource center, and we can borrow it and do this breeding part. So in sources of plant germplasm, one is we can collect it from jungles, wild relatives, then land races and primary cultivars from farmers, then obsolete and defunct cultivars. That means people have abandoned them and store somewhere. In some places, you can find rare some varieties, cultivars. You can use that one also. Then advanced breeding lines and other products of plant breeding programs. Then current cultivars. I want to tell you one very good story about this germplasm. We have a very good germplasm in Sri Lanka, Plant Genetic Resource Center. Then we have a very good germplasm in Philippines for rice cultivation. Then another place we have that I can't remember the country, but there are places where you get this plant germplasm collected in one place. So finally, the USA wanted to have this germplasm protected, because otherwise it will be destroyed sometime due to war or due to any other kind of disasters. So that USA decided to collect all these germplasms into their country from Philippines, from Sri Lanka, from the other countries, so that they have a germplasm, worldwide collection of germplasm. Now they can use it. And we are unfortunate that we don't have that kind of right to keep that without giving them. So that is one example. The other example is we have some chili varieties and maize varieties. These are very highly improved. For example, these varieties, they have taken our maize varieties, and finally they got a hybrid variety from our varieties, and they sent to us by using another name like Pacific. And they wanted to, the problem of hybrids, because you can't produce seeds. So the people who know that, they have their parent seeds and they produce seeds. So these hybrid seeds came to Sri Lanka and they sell first at a lower price. Now it is a very high price, but now farmers are addicted to use these hybrid varieties. So those are really originated in Sri Lanka and some other countries. Finally, it has gone to some other countries, and they are the people now who own these crops and varieties. So you see the unfortunate things. When you look at this plant genetic resource, a crop can be improved or developed. These plant genetic resources coming from land races, farmers' varieties, they call family secrets, then parental lines of hybrids, if you have, then genetic stocks somewhere, then primitive cultivars, wild and weedy relatives, and also already released varieties. All these we can use as genetic resources and develop a crop. And the problem is, what is the purpose of developing a crop? Purpose may be high yield. Purpose may be pest tolerance. Purpose may be drought tolerance. Now, when we are going to discuss about green revolution, we can discuss further about the purpose of crop improvement in those days to increase the crop yield. So we have lost a lot of other properties, and finally we have come out with some low quality but high yielding crop varieties. So that is another case that we faced in 1960s due to Green Revolution. We have in Sri Lanka plant genetic resources. We have 7,500 plant species constitute the flora of Sri Lanka. Flowering plants constitute about 3,360 species, belong to 1,350 genera and 200 families. The flora contains by about 830 endemic species. The low country wet zone and mountainous areas in southwest harbor 90% of endemic species because it has not been disturbed. Over 600 species have been used as medicinal plants. Over 600 species, a number of cultivated food plants have their wild relatives. For example, we have jackfruit as a wild relative, then breadfruit, citrus, then mango, so many yams, then pepper, rice, pigeon pea, and cardamom. So that we have a lot of wild species. So that is our genetic resource. Now here you can see that pigeon pea, we have our traditional varieties. At the same time, we imported some varieties like ICPL 1, ICPL 2. Now we are having a good potential to grow pigeon pea because that is drought resistant or drought tolerant and good yield, and it is good for food. Unfortunately, now it has gone away again because farmers are reluctant to grow it without any reason. So that we have lost a good crop, pigeon pea. So we have plant genetic resources, pigeon pea wild variety we have. Biodiversity. Now we have different ecosystems. In these ecosystems, these ecosystems are rich in biodiversity. There are global biodiversity hotspots because those are rich biodiversity systems, ecosystems, and these are threatened in relation to biodiversity decline. So that we call hotspots. Sri Lanka also have some kind of hotspots for ecosystem biodiversity. Terrestrial ecosystems include tropical lowland rainforest, where 90% of the endemic woody plants and 75% of the endemic animals are found. Now, we have our endemic species, a lot of endemic species. We'll have to conserve them, preserve them. Otherwise, it will be lost for some time. We have collected data and we have developed reports. And you know that Red Book developed by International Union for Conservation of Nature. After 4 or 5 years, they used to update it, and it will show that which species, flora and fauna, will go soon or will be threatened. In terrestrial and freshwater ecosystems, freshwater crabs, 98%, amphibians, 85%, and land snails, 83%, show the highest endemism. So we have a very rich biodiversity in this regard. The conserved biodiversity would provide a wide range of ecosystem services. Now, what is happening that we are not concerning about this diversity. Because of that, we have removed a lot of species for different purposes, and our ecosystems are now being degraded. Right? Agro-biodiversity is really agriculture and biodiversity. The variability of this is plants, animals, and microorganisms, and genetic species and ecosystem level, which are necessary to sustain key functions of the agro-ecosystem, its structures and processes. Now it is time for us to think about biodiversity and agro-ecosystems, because we have forgotten all these and try to get maximum production from a piece of land, leaving all other valuable things like biodiversity and ecosystem services. So that now we are in a very unfortunate situation that in future we have to give more concern on this sustainability we have to ensure, especially, and we have to improve our biodiversity and the ecosystems. Agricultural ecosystems for the production of food, fiber, fuel, and fodder, to conserve the ecological foundations to sustain for future, to allow adaptation to changing situations like climate change, natural disasters, etc. Now, our battle is they are to face climate change. We have our this traditional knowledge, indigenous knowledge. We have our new technology. With all these, now we have to face climate change. Climate change will tell us, according to Paris Agreement, we are supposed to reduce our greenhouse gases. And also we have to improve the carbon sequestration in the soil, so that during last 3-4 months, we had an attempt to make a report to develop the strategic plan, how we can put this into a balanced system by the year 2050. So that we found that especially agro-ecosystems, that is the concept that we have to maintain in future rather than production-oriented agriculture. Biodiversity, we have different types of biodiversity. One is genetic biodiversity, same, but genetically different. Then species diversity, variety of species in a given area, species. Then ecosystem diversity means there are different ecosystems, especially if you talk about our rural areas, you can have different ecosystems. One is paddy ecosystem, tank ecosystem, Chena ecosystem, so many ecosystems. How we can think of this diversity? One is habitat diversity. Land use varies with soil and terrain. So habitat is there. If you destroy a habitat, that is the end of that particular flora or fauna. Then interspecies diversity, different species of plant, animal, and microbiome. So intraspecies diversity means that is within the species, there are different genes, resources, unique traits, which are sometimes you can use it for the purpose of crop improvement, resistant to drought, cold, disease, routine, so many things. Then harvested species means sometimes you use these like wheat, rice, maize as food. So that is harvested species. So what are the benefits? One is environmental benefits. So you can have very pure air, water, and soil quality, improves wildlife habitats. Then you can get economic benefits, energy conservation through crop mixing, which is the basic idea of agro-biodiversity. Then social benefits, quality of life, the fresh environment. You can develop your mind towards a calm environment. So that is the one that we have to talk about. Agricultural biodiversity means a lot of other benefits you get from this agricultural biodiversity. So that we have to keep in mind that it's not the production, it's not the yield, it's not the quality of product, but also the diversity. So when we see that the agricultural landscape is losing the biodiversity, it affects not just the production of food, fuel, and fiber, but also a range of ecological services supporting clean water supplies, habitats for wild species, and human health. So many examples we can talk about this loss of our biodiversity will lead to loss of a lot of other purposes. Finally, when agro-ecosystem biodiversity, for that we need different components: soil, mesofauna, microfauna, earthworms, non-crop vegetation, herbivores, so many things, not only the crop in agro-ecosystems. And functions are there. Sometimes you can regulate the population of different species, biological control, biomass can be increased, nutrient cycling can be promoted. Then allelopathy effect can be there to reduce sometimes the competition, soil structure, nutrient cycling, decomposition, and so on. Enhance, what we have to improve that. One is we can do intercropping, crop rotation, no tillage, green manures, windbreaks, agroforest systems, composting, organic matter input.